So what we're looking at here is f of g. I want you to pay real close attention to this symbol right here. Now, while it looks a little bit like a dot, it's not a multiplication dot. It's not a multiplication sign. It's a composition sign, and it means f of g. F of g. You might see them like this or like this. Okay, it does kind of look like fog. But it's actually an operation, just like add, subtract, multiply, and divide, just like square roots and squares and absolute value signs. This is actually an operation. It means take g and plug it into f. So it means plug the function g of x into f of x. That's what it wants you to do. All right, so that's what we are going to do. So I've got two different functions up here. I've got f of x and I've got g of x. I got a quadratic function and a linear function. We're going to plug the linear function into the quadratic. So what does it look like? Well, let's see. F of x looks like 2 times something squared, right? Plus something minus 1. Does that look like it? Okay, I'm going to get rid of that. All right. Well, what is that old something we're going to plug in? Okay, we're going to plug in g of x. So we're going to take that and plug it in here. And don't do that. Plug it in here. So we're going to plug in 2x plus 1 and 2x plus 1. And now it's just up to us to simplify. We're going to use all of our rules for simplifying. So look up here and tell me, how am I going to simplify these parentheses to the second power? Yes, that's correct. It is a FOIL problem. Thank you for noticing that it's a FOIL problem. So I know right now that I have to do 2x plus 1 times 2x plus 1. And if you can do that in your head, that's perfectly fine, but that's got to happen first. So what does that simplify to be? 4x squared plus 4x plus 1. Right, you were doing it in smaller steps instead of putting them together. That's fine. And now you can multiply by this 2. And you can add the rest of it, which is 2x plus 1 minus 1. Do you guys want to go ahead and get rid of the plus 1 minus 1? You could, right? They're like terms. So if you want to, you could go ahead and add those together, get rid of them. Or you can wait till the end, it's fine. All right, now how are you going to address this? Okay, you do have to use a distributive property. Now you can use the distributive property here, and that gives you 8x squared plus 8x plus 2 plus 2x. And since we went ahead and got rid of the plus 1 minus 1, I don't need that anymore. And anything else to clean up?
8x squared plus 10x.
Yeah. So that's going to be, I just barely ran out of room. So that's going to be 8x squared plus 10x plus 2. That is the function f of g. Looks like fog, right? Or you could also say it f parentheses of g of x, like this. Those both mean the same thing. That's a new syntax for us. That's a new way of writing things, so recognize that these two things mean plug g into f. That's our new function. Okay? Any questions? All right. G of f. Is that different? Different? Okay, it definitely looks different, but is it the same concept? Absolutely. You're going to do the same exact work or concept. It's just going to be the other way around. So this time, instead of plugging g into f, you're going to plug f into g. So I'll try to keep the colors straight. Let's see, g was green. So my g function, let's see, my g function was 2x, so I'm going to leave a space there, 2x plus 1. And I'm going to plug what in its place? That's right. The function 2x squared plus x minus 1, because that's the function f. Now, how do I clean this up? Yeah, I can just go straight to the distributive property here, right? So that's 4x squared plus 2x minus 2 plus 1. And that leaves me with 4x squared plus 2x minus 1. That is g of f, or we could write it g of f of x. Okay? Does that make sense? Okay. Anything new, really? We kind of did this when we were doing polynomials with algebraic expressions, but this time we're just doing the entire function. All right, without talking, just as an introduction to inverse functions, we haven't really looked at what they do and what they look like and that kind of stuff, but this is one of the definitions we need to know, that two functions are going to be considered inverses if and only if both of their compositions are the identity. Now, I do need to remind myself, what is the identity function? It's the function y equals x. It's the function y equals x. If I plug in a 1, I get out a 1. That's the identity. If I plug in a 2, I get out a 2. If I plug in a 3, I get out a 3. Y equals x is your identity function. Okay? So what I want to happen is I want to come down here and I want to do f of g, and I want to get out the answer x, just plain old x. And then I want to come over here and I want to do g of f, and I want to get out an x. Okay? So that's what we have to do. If these two functions are inverses of each other, then when I plug g into f, everything will cancel out, and except for the x. And vice versa. If I plug f into g, everything will cancel out. So we're going to see if that happens. Okay? We're going to see if that happens. Let's see. So let's see. I'm going to use some colors here. I'll try to be consistent. So we'll call f red. And we can use blue. That's fine. G will be blue. All right. So I'm going to do g into f. So it's going to look like this. See, f is red, so that's 2 times something to the second power minus 1. And that something is function g. So I'm going to plug all that in right here. Of course, that looks like square root of x plus 1 over 2. Now, it's my job now really just to start simplifying the best I can simplify. So remember our laws of exponents. Do I mess with this 2 first, or do I have to mess with the parentheses? Okay, I do have to deal with the parentheses first. This exponent, okay, so I'm just going to ignore this 2 for a minute. So basically, I'm concentrating right here. And if you really want to think about it, that problem says square root of something squared. That's what this says. It says the square root of something squared. Well, what do we know about a square root and a square? They're opposites. They're inverses. What do they do? Cancel. Most of you would say they cancel, right? So I'm just going to cross that out. And that leaves me with 2 times x plus 1 over 2, subtract 1. So the square and the square root canceled each other out. So now I'm looking at this. Obviously I have parentheses. I obviously have to multiply. Do you recognize the multiplication right here? So some people do have a hard time with this multiplication. They forget that it's over 1. So basically in your head, this is what you're thinking. 2 times x plus 1 over 2. That's what this means right here. So what happens to these 2's? Okay, these 2's cancel, don't they? I'm loving it. So those go away, and that leaves me with x plus 1 minus 1. And do you see what happens with the plus 1 minus 1? They go away, don't they? So I've got x. So f of g gives me a plain old x, doesn't it? What did we call this?
Inverse.
Well,
Well,
this is the identity. This is the identity function. Now, what we just found out, a lot of you said inverse, and you are right. G is the inverse of f, but I have yet to show that f is the inverse of g. So I have to do both of them. But I'm halfway there, right? All right, so now we're going to come over here and do all the same work with plugging f into g. So let's see, g is in blue. So g is going to look like the square root of something plus 1 divided by 2. And what is that something?
2x squared minus 1.
Good, that something is the function f, and I'm going to plug it in right here. So it's 2x squared minus 1. I just got to start simplifying. Where can I simplify first? I can take care of the negative 1 and the 1, right? There's no exponent above this parentheses. There's nothing for me to do. These parentheses I really don't need, do I? So I've got minus 1 and plus 1. So that leaves me with the square root of 2x squared over 2. And I think most of you see immediately that the 2's are going to go away, right? So those 2 will kind of go away, and that leaves me with the square root of x squared, and again, that's just a plain old x. And I got a little sloppy. I lost all my equal signs. But g of f gives me x. Do I like that? Why do I like that? What is this? Is this the identity? All right, this is the identity function. So, did both of these give me the identity? They did. What does that tell me about these? Tells me they are inverses. So these both gave me the identity. So back to the original question, are these two functions inverses?
Yes.
The answer would be yes.
You see that like right at the beginning?
Well, sometimes you can. Sometimes you can. It's a good question. You know, if you recognize this one's got a square root and this one's got a square. Right? This one's got a minus 1, this one's got a plus 1. This one's got a multiply by 2, this one's got to divide by 2. So yeah, you can recognize that sometimes they are, but sometimes they can hide them too, and it's harder to see. But we know for sure by showing our work that if we plug each function into the other one and we get the identity for both of those, then it is, they are inverses of each other. What would happen if these were not x? Then they would not be inverses. That's right. So I'm not going to do another example so that you can get started on your work. But if I do these and they're not x's, then the answer is no. If I do these and the answer is x, then the answer is yes. I do have a question for you real quick. What's the opposite of addition? Subtraction. Okay, I said opposite. I should use the word inverse. What's the inverse of addition? It's subtraction. What's the inverse of multiplication? What's the inverse of square root? Square. What's the inverse of this function? The other function. That's what happens. They undo each other. Okay?